Hi, we're going to look at dividing rational expressions. So if you know how to multiply, you know how to do division. So when you divide fractions, we don't like dividing fractions, so we could change it to multiplying. And we have to multiply by its reciprocal, meaning beginning problem stays the same. We turn this to multiplication, and then we flip the fraction. We do the reciprocal, 8x to the third, 5y. So I'm going to rewrite this. Instead of dividing, I'm going to multiply by the reciprocal. So I'm taking that problem, I'm going to flip it over. Now, let's just cancel things out. We have 1y, we have 2y's, giving us one extra y there. I have a 5 and a 15. They both share a 5, so 5 goes in there once, 5 goes here 3 times. X's, I have 1x, I have 3 x's, giving us 2 left over. And then 4 and 8, 4 goes in the 4 once, 4 goes in the 8 twice. And what are we left with? 3 times 2, 6, y and x squared, so x squared y. And then on the bottom, 1 and a 1, we don't need anything, you're done. So the only difference is we're multiplying instead of dividing, and this second fraction, we have to do the reciprocal. So we multiply by its reciprocal. So let's do this again. Instead of division, I'm going to rewrite this and say times 14a squared c, 8x squared y. We don't need that. You multiply by the reciprocal instead. Now let's start simplifying. 21 and 14. Something on the bottom, or something up top, something on the bottom. They both share 7. 7 goes in there 3 times. 7 goes there twice. A's. There's 1 there. There's 2 here, giving us 1 left over. C's. I have 1. I have 1. They disappear. How about 8 and 2? They both share 2, so 2 goes in here once. 2 goes in there 4 times. And here's where we can kind of do a little bit of work. 4 and 3 multiplied together give me 12. I have 12 collectively on the bottom. I have 12 on top. They cancel out. I have 2 x's here. Here there's 3, leaving us with 1 left over. I have 1y. There's 2 there, leaving us with 1 left over. And we're going to rewrite what we have as what we've got left over. And I understand this is messy looking, but it's a lot of canceling. X, y, and a all over nothing. So there's your answer, x times y times a. Okay, so what if you've got binomials being divided? Well, okay, so a couple things. So this problem, we need to factor this first half. So they both share 2 up there. I'm going to pull a 2 out, and I'm going to rewrite that. That's gone. Okay, this, I want to turn into a fraction. So I can put it over 1. But it's with division. I don't like division. We want to multiply by its reciprocal. So I'm going to actually kind of take a shortcut here. I'm going to turn that to multiplication. And then do the reciprocal by that. Now, do you have anything up top and anything on bottom that's the same? X plus 3, x plus 3. And that's pretty much all. You're left with 2 over x squared. Just got to factor stuff. Well, we got to factor and we've got to move. So let's factor this first one. X, 2, 1. To get a positive 3, we need plus 2 plus 1. That's gone. We're going to turn this to multiplication. And remember, these have to get flipped. So x squared plus 4 comes up top. And then x plus 1 on the bottom. Now, let's see if anything cancels. X plus 1, x plus 1. Can we simplify that? No, it's not the difference of perfect squares. It's perfect squares, but it's not the difference. So our final answer we can just leave as x plus 2, x squared plus 4, all over 12. And we do not need to multiply them together. We can leave them broken up like that. And that's dividing rational expressions.